Okay, so for number 9, he has 8 ties which go well with the sports coat. So the probability that it'll go well with the sport coat, there's 8 ties that he wants out of 15 ties total. As nice as that, that's part A. So the probability that it does not go well with the sports coat, there are 7 remaining ties that don't go well. If 8 go well, then 7 don't, because there have to be 15 total. So 7 out of 15 is your probability for B. Odds against it going well with the sport coat. So odds against are always number unfavorable to number favorable. So there's 7 ties that you don't want, 8 ties that you do. So the odds against are 7 to 8. And for D, you just switch those. So odds in favor would be number favorable to number unfavorable. So there are 8 ties that you want and 7 ties that you don't, and they should always add up to the total 15, unless it's reduced. Right. So that's number 9. And on to 13. So 13, die is tossed, determine the odds against rolling a 4. So odds against, we want number unfavorable rolls to number favorable. So we want to get a 4, so there's only one possibility that we want, and the other 5 numbers on the die we don't want. So 5 to 1. And that's it. That's all for 13. So for 17, card is picked from his deck, odds against and the odds in favor of selecting the queen. So odds against, again, unfavorable to favorable is the odds against. So one favorable, actually wait, there are 4 queens in the deck, so 4 favorable cards that we want, 52 cards total, so that means 48 cards that we do want. And so if I, 4 cards that we want a queen, 48 unfavorable cards. So if we were to reduce that, divide by 4, we get 12 to 1. So if that are the odds against for part A, then the odds in favor would just be that switched, so 1 to 12. And that's it. So on to 21. Odds against the spinner landing on red. So odds against the spinner landing on red. So we want not red to red, the odds against it being red. So we're going to list the not red first. So looks like there's 2. If we divide the spinner up into 4 parts, there are 2 parts that are not red and 2 parts that are red. So basically 1 to 1 chance. And that's that. 21. Next one is 41. Let's see. playing bingo. When playing bingo, 75 balls are placed in a bin and balls are selected at random. Each ball is marked with a letter and number as indicated on the chart. So we play bingo. See the probability that it contains a G. So they have all those numbers listed, right? And basically, all of these, only 1 out of 1, 2, 3, 4, 5, 1 and 5 contain a G. It's all divided up into 5 lines. This whole line has G's and the rest of them don't. So 1 out of the 5 lines have G's. So that's 41. And then for 45, the odds against it being B9. So there's only one way to make B9, and that's your favorable one, right? So the number of unfavorable, all the rest of the balls that they could pull, how many possibilities do we have total? Bingo is the numbers. There are 75 balls total, they tell us in the beginning, 75 balls. So 74 that we don't want. There's only one B9 and 74 other balls. So 74 to 1 are odds against it being B9. So that. And so for 49, odds against a person having A positive blood. So again, I keep doing odds against, which is very negative. So we want unfavorable to favorable. So our favorable is A positive, and our unfavorable is simply not A positive. So if you look at your chart, A positive, 34% have A positive. So the rest of it is not A positive. So 66, because it has to add up to 100%. So if 34% have A positive, then the rest, 66%, don't. And so if you just simplify that, divide them both by 2, 32 to 17. Just check that to be sure, because they seem like weird numbers. 49, 12, 4, 49, 12, 3, 49, 33, 17. Yep, we're good. So, last one, 53. So for 53, suppose that the probability that a rock concert sells out is 0.9. Determine the odds against the rock concert selling out. So unfavorable to favorable are your odds against. The rock concert selling out is 0.9. So the probability that it doesn't sell out is 0.1. So if you just multiply these both by 10, you get 1 to 9. So 53, 1 to 9. And that's